Okay, so now we are going to do model number one, which is another way that these problems can be presented to you in sort of like this word problem format. So Rowan is training to run in a race. He runs 15 miles in the first week. And each following week, he runs 3% more than the week before. Using a geometric series formula, find the total number of miles Rowan runs over the first 10 weeks of training, rounded to the nearest thousandth. So luckily they did tell us that we are going to be using this formula. That's not always the case. They don't always come out and say that you're going to be using this formula. You have to understand that this is exponential growth. Every week he runs 3% more miles than the week before. And exponential should remind us that we are working with a geometric sequence and we are finding the total number of miles he ran for the 10 weeks. So all of these clues to us in the future, we might have to bring all of these clues together to understand that we should be using this formula. Again, it doesn't always come out and say that we should. Luckily, it does here. So basically the value we're finding is we are finding the total number of miles he ran in the 10 weeks, right? So I've made 10 blanks, so technically the longer way would be to figure out what the number of miles is for each week and then add them up. But we're going to utilize the formula because why not? They told us to. Okay, so now we're finding the sum of the first 10 terms, the first 10 weeks, the number of mileage. So they told us he ran 15 miles the first week, so we're going to sub 15 in there and there. Now the ratio. The ratio is going to throw some students off. The most common mistake, which is about what we're going to do right now, is students will sub in 0.03. And you can understand why they would do that, because they see a 3% weekly increase. And 3% we understand as a decimal is 0.03. Let's see how this turns out. Because again, this is the common error. This is sort of what we want to stay away from, which is why I'm going to put a big X over it. But let's sort of go through with it, and hopefully if you were to, again, put the 0.03 in for R, which is the incorrect thing to do, hopefully we can understand and catch yourself in the mistake by thinking about our final answer. So I'm going to go ahead and put in all of the values that we need. And check this out. So when I press enter, the final answer is 15.4639, etc. miles. Now, if you understand what you're finding, you are finding the summation of all of the miles he ran in each of the 10 weeks. 15.4639 makes no valid sense whatsoever, because take a look. He ran 15 miles his first week, and then the second week he ran 3% more than 15. So he ran, something a bit larger than 15. So you're already at 30 plus miles after week 2. So if you can logically make sense again of what this value really means, hopefully you would be like, oh, that doesn't make any sense. The proper common ratio that we should be using is 1.03, and that comes from doing 1 plus the percent increase that was mentioned. So very, very good if you thought about it a little bit and came up with that 1.03 yourself. So the common ratio is going to be, in this case, 1 plus the percent increase. And that's because, again, this modeled exponential growth. In the future, for instance, in the next problem, our common ratio is going to be found by doing 1 minus the percent decrease. All right, so if they're talking about exponential decay, it's going to be 1 minus that. But here we go. We're just going to pop in the correct way of doing it, using the correct common ratio, and we're going to get an answer that makes more sense 171.958 miles, which is a more logical total for the 10 weeks. All right, there's your model number 1.